Okay, so we're going to derive the law of cosines today. So what we're going to do is we're actually just going to draw a triangle, but I'm going to draw the triangle on the XY plane, so the coordinate plane. So here's my triangle. I'm just going to draw whatever, just any old triangle. I always just like to make them acute just because that's easier for me to draw, but you could draw it. You can actually do this anyway. You could do it with another kind of triangle, and maybe the height would be outside the triangle. You know, it doesn't matter which way you draw a triangle. This is just the way I'm going to draw it, okay? So let's label this triangle a little bit. We'll call this ordered pair up here x comma y, because we don't know what it is, so we'll just call it x comma y. It's just a generic one somewhere on the vertex of the triangle, okay? So that means that this distance right here, hopefully you can see that that distance right there means that this is y. Does that make sense? And then that this one right here is x, because if this is xy, well, this is to x and it's y. So hopefully you can see that, okay? I'm going to label the sides. We can call them, again, anything you want, but since usually the formula has an A, B, and C in it, I'm going to call them A, B, and C. So I'll call this one A and this one B, and I'll make this side of the triangle C, okay? So that makes this over here angle A, and this one angle C, I guess, and this one angle B. Okay, so there's my triangle. All right, so for the law of cosines, we're going to be talking about the one case that you really can't get to with your law of sines, and that's if you don't have an angle and a side that are opposite each other. So in this case, we're going to be working with an angle and a side that aren't opposite each other. We're going to be trying to write the formula so that we can find, you know, this information if we had this one or vice versa, okay? Because as you know, in the law of sines, you need to have an opposite side and angle to be able to use the formula. So what I'm going to do is I'm actually going to be finding the length of this side in essence, okay? Given that we have this angle, let's say, okay? So what I'm going to do here is if I'm trying to find the length of a side, if we're trying to find distance here on a coordinate plane, well, that's kind of easy if we have two coordinates to work with. And we have this coordinate, xy, and we actually kind of know what this one is too, because if this distance is c, then that's c comma, well, it's right on the x-axis, so it's c comma 0. So we know the coordinates of that one too, which means I can describe the distance of this side, or in other words, the length, the distance between these 2 points, or the length of A. Okay, so that's what I'm going to do. I'm going to describe it using my distance formula. So here we go. I'm going to say that A is equal to the square root of x minus c squared plus y minus 0 squared. Okay, so again, great, that's awesome, but I don't really have any trig in there, right? And I'm trying to get to the law of cosines. So somehow I'm going to have to convert this information to, you know, cosines. So let's go back to our triangle, and there's a reason why I drew this in for two reasons: to find this, you know, coordinate, but also because now we have a right triangle. Do you see that? And so that means I can use my trig ratios here. So what can I describe here? Well, we can talk about angle A, right? Because that's the angle down here with that triangle. So let's do that. We'll say, let's see, cosine A would be what? Adjacent over hypotenuse. So cosine A would be x over b. Or we could say that b cosine A is equal to x, which I like that one because that will help me replace something in my formula. Okay, so I already have something I can replace in my formula. Let me zoom out just a smidge more, just so I don't keep going off the screen here. So I can already say that A is equal to, well, let's get rid of that x right away. I'm going to call it b cosine A. That's great because that gets rid of a x, and it gets my cosine in there, just like I wanted, right? All right, so let's talk about the y also, because actually I can't really talk about c because it's not in the triangle, so I know I can't really get rid of the c, so I'm just going to leave him as c. But the y is in the triangle there, so I can change that to something related to trig, right? I could say that sine A is equal to y over b, or in other words, b sine A is equal to y. And again, we kind of know that stuff from using our unit circle and those ideas. So we know that one, y, I'm going to replace with b sine A. Now, of course, since this is minus 0, I'm not even going to write the 0 anymore, okay? So I just replace the y. I replace the y with b sine A. The 0 I just didn't write because, well, minus 0, you don't have to write that every time, right? He's kind of like we evaluated that subtraction already, in other words. Okay, so now what am I going to do? I'm going to simplify this thing up as best I can. You ready? So to get rid of the square root, I'm going to square it. So we'll say a squared is equal to, so that gets rid of this radical. I squared both sides. Okay. Now we'll square this little thing. So I'm just going to do it all in one step so I, just save myself a little bit of writing. Now, hopefully everybody knows we have to FOIL this. So if you don't know how to FOIL it without writing them side by side, then go ahead and do that. But hopefully you've been FOILing these things long enough that you kind of can do it without writing them all out. Oh, plus c squared because it's minus c times minus c. So again, what did I do there? I did b cosine A minus c times b cosine A minus c. And when you FOIL those out, of course, that's where I got this thing. Okay? Then let's square this one, so it'll be plus b squared sine squared A. All right? Now what am I going to do? I'm going to try to get rid of the sines because this is law of cosines. So I'm actually going to do that by using one of my trig identities. And I see these two make me feel very happy because I see a cosine squared and a sine squared. So I'm actually going to write them together. And I'll just do plus c squared, and what else is up there? 2bc cosine A. So the rest I just carried down. So I moved these two together. You see them? That was these two. Oh, I just moved the c in front and there. Okay? So then I just wrote the rest of the stuff. Now what am I going to do? I'm actually going to factor out the b squared. I lost my squared. So I'm going to factor out the b squared, and that leaves me cosine squared A plus sine squared A, and hopefully everybody's like, oh, that's beautiful. All right, all my trig students should be saying, what a wonderful, wonderful thing that just happened here. So let me see if I can move this up a little bit. My camera's not positioned quite right today. All right, so I'm going to convert this to a 1. Because, of course, my Pythagorean identity says sine squared plus cosine squared is equal to 1. So I get a squared is equal to b squared times 1, so I'm not going to write it, plus c squared minus 2bc cosine A. And this is actually the law of cosines. We just found it. So why did I want this formula? Well, as I said at the beginning, if I have the cosine of this angle, but I don't know the length of this side, I can actually, and like I know the other sides, I can figure out a side. I can figure out a triangle where I don't have a side and an angle opposite each other, which I cannot do with the law of sines. So this is my law of cosines. Now, sometimes in the book, they switch around all the letters. Like they'll say b squared is equal to a squared plus c squared minus 2bc cosine b. But hopefully everybody knows it doesn't matter. You can change those letters to anything you want. This just means it's a side. This side has to be opposite this angle, right? I could call them anything, right? I could call it rainbow squared is equal to, I don't know, pot of gold squared plus, I don't know, triangle squared minus 2. Now I don't know what I did here. Oh, this would be, oh, sorry, AC. See, I screwed it up. Pot of gold, triangle, cosine, rainbow, right? It doesn't matter what you change them to. It could be anything you want, right? You just, if everywhere that there's a B, you have to change it with whatever you're changing it to. Everywhere there's a C, you're changing it to whatever you're changing it to. And these two things have to be the ones that are opposite each other. It doesn't matter. So when the book lists them in all these like 3 different formulas, it's kind of stupid because it means the same thing, right? It's a formula. You can change it to whatever variable notation you want it to be. Now, the other thing that sometimes they do is they solve for the cosine, which isn't the worst thing in the world. But again, I don't usually bother with it because that's easy enough to do. I don't memorize it that way. But if you wanted to solve for cosine, right, you could do so if you wanted to solve for the angle instead of the side, like if you knew the 3 sides and you wanted to solve for that angle, of course, all you do is you subtract, right, is equal to negative 2bc cosine A. So I subtracted the b squared and I subtracted the c squared from both sides. And then I would divide by the negative 2bc. And I would have, I guess since I don't like this negative sticking out front, I'm going to do b squared plus c squared minus a squared. So I kind of moved the negative to the top. Does that make sense? And again, I don't bother to memorize this because if I know this one, then I can get to that very quickly, right? Even if I can plug the numbers into this one and still solve for this afterwards. So for me, to learn this one isn't worth my brain energy. To think about, I have to think about it with all the different kinds of numbers plugged, variables plugged in seems ridiculous to me. So this is what I memorize and this is what I work with. And you can see where it came from. It came from this picture that we've used like a billion times. All right. And all the law of cosines questions are just plugging them in. And actually, there's no ambiguous case for the law of cosines. And let's just talk about that real quickly. So for the sine one, right, we have to be careful. But let's think about cosine for a second. So if we have a triangle and we're solving for, the sides and angles of a triangle, well, what quadrants can we find an angle that fits inside of a triangle? We can only find that in quadrant 1 and 2, right? So this quadrant and this one have, this is where angles small enough for triangle live. Does that make sense to everybody? So these are the angles from 0 to 180, right? From 0 to 180. So that means that anything past here isn't going to fit in a triangle because you have to have angles smaller than 180 if they're going to fit in a triangle, right? So let's think about it for a second. If you have something like cosine A is equal to negative 0.135, well, what do you know about that? You know that it could be in this quadrant or this quadrant, right? That's where A could live. But since you know that this one is in a place where a triangle could have an angle, then you know that it has to be the angle in this quadrant, right? So you know that this really has only one solution that fits in a triangle. Does that make sense? And of course, if you had, what would be the other option? You could have like cosine A is equal to 0.735, right? And so since we know that it's positive, it could live in this quadrant or this quadrant. But once again, quadrant 4 doesn't have angles that will fit in a triangle. So you know that it has to be the one in quadrant 1. So that has only one solution in Q1, right? That fits in a triangle. So law of cosines doesn't have that weird situation where you can end up having, so this one would have to be in Q2. This law of cosines doesn't have that weird situation where, sine, both of these are positive and both of them could fit in a triangle. So sometimes you get a case where it could be 2 solutions. Law of cosines never works that way. So there is no ambiguous case for the law of cosines. It's really just using this formula. The only thing that could happen is that you have one triangle or no triangles possible. Those are your only 2 options for law of cosines. Okay? What do you think? So try some law of cosines questions today and let me know how it goes.